is up, Geo Metro Ninjas, and welcome to another fantastic day in geometry. Today we get to talk about congruent arcs and congruent chords. So we learned that an arc is simply a portion of our circle on the edge that falls between two endpoints. We have minor arcs that are always named with two letters. They are less than 180. We have major arcs used three letters, the endpoints and then 1 point between, that is greater than 180. And then we have semicircles, three letters, endpoints on the diameter, and they are equal to 180. Today we're talking about arcs and chords as they are related, is our first theorem. Two chords are congruent if and only if their corresponding arcs are congruent. We have seen this if and only if phrase before. If and only if represents a biconditional statement. So a biconditional statement means what? Does anybody remember? Absolutely. It means that a statement, a biconditional statement, means it is true, whether we're talking about the conditional statement, which is as it stands, if two chords are congruent, then their arcs are congruent, or the converse of that statement, which we just flip them forwards and backwards. If two arcs are congruent, then their corresponding chords are congruent. So biconditional means they both must be true. So if you see this first diagram, okay, AB is congruent to DC, so that means arc AB is congruent to arc DC. And then we can say the same thing for AD here. As long as segment AD is congruent to segment BC, then their corresponding arcs are also congruent. So just like our segments, we signify congruence with tick marks on the edge of our circle. So remember, arcs exist on the edge of our circle. Yes?
What are those? Is BC and AD?
BC and AD are congruent. They did not label them correctly. Oh, I see what you're saying. Yes. So the way it's drawn, they are not. I'm sorry. Good catch. That's what I'm talking about. So we see that good catch, student save, they are not the same length, therefore arcs are not the same length. But AB and DC are, so we're going to stick with that. Good catch. Okay, so looking at number one, find the value of x. So right off the bat, they don't really tell us anything outside of xz is congruent to yz. But the theorem we just talked about, if our chords are congruent, remember a chord is a segment in our circle with endpoints on the circle. If that is true, then what can we say about our arcs? They are equal. The measure of xy equals the measure of yz, or xz. Xz equals yz. And mathematically speaking, if things are equal, that means we can solve for something. So 127 equals 5x plus 17. Subtract 17. 110 is 5x. Divide by 5. So x is 22. Sure. 22. One more time. That's all we got to do. If the chords are congruent, the arcs are congruent. That was actually that homework problem we had last night where it was talking about the measure of arc AC, and then it told you the chords were congruent. They just jumped the gun on you a little bit. Okay. So remember, it is biconditional. So this time they told us the arc was congruent, but they want us to find the length of the chords. Since our theorem is biconditional, we can use it to say, like on number 1, the chords made the arcs equal, or we can use it the other direction to say the chord or the arcs make our chords equal. So finding the length of AB, we know that our chord AB equals chord CD because arc AB is congruent to chord CD. So 14x minus 30 equals 12x minus 8. We've got a variable on both sides, so we're going to move that variable first. So we're going to subtract 12x. Two x minus 30 is negative 8. Now that we've isolated our variable, we can go ahead and move that constant, add 30. So the question was, are they always congruent? If the chords are congruent, then the arcs are congruent. And then the vice versa is true. If the arcs are congruent, then the chords are congruent. But mathematically speaking, if they weren't congruent, there's really nothing we could do here. So we've got to be able to solve for something. Any other questions on, oh, we need to find AB, don't we? So we're going to substitute that value for x we just found. So 14 times 11 minus 30. 14 times 11 is 154. And 154 minus 30 is 124. It's a big old circle. Any other questions on number 2? All right, let's look at number 4. Number 4 is a little different. We've still got our congruent chords, but what's wrong? We're missing the other arc, absolutely. Or are we? They're equal, so what does that mean to us? Arc is the outside edge of a circle, just a portion of it, not the whole thing. One more time. It cannot equal x because we don't know what x is. We don't want to create a second variable, so it does equal itself. If ED is 4x minus 8, EF also has to be 4x minus 8. Now, we cannot just set them equal to one another because what that does is create infinite solutions because at any point, a number is always equal to itself. So we can't just say 4x minus 8 equals 4x minus 8 because that's always true and that's not going to solve for us for x. What do we know about the entirety of this circle, though? The whole circle is 360. Do we know all 3 of the portions of the circle? Yes. So what we're going to do is we're going to go 4x minus 8 plus 4x minus 8 plus 84 is 360. So essentially what we did was we took the 2 arcs and then added it with the df that we knew that they gave to us. You 100% could have just subtracted 84 minus 360, and you could even take that a step further, subtract 84 from 360, and then divide by 2, and just set that equal to 1 4x minus 8. Okay? So we're going to combine like terms. Okay? So 8x, 84 minus 16, 68, thank you, is 360. So now we're going to subtract 68 from both sides. So 8x is 292. And then divide by 8. Did I mess up somewhere? Negative 8 minus 8 plus 84. 68 minus 360. We got a decimal, didn't we? Them rascals. I hate when they do that. 36.5. It looks like it. We went back, we checked our work to make sure that's what we were supposed to have. So it could have. Yes, ma'am. So that is, we haven't learned that yet. So that's called an inscribed angle. So yesterday we did talk about central angles, but that would have to come from here. Then this would be 84. Okay. This is what we call an inscribed angle. We'll talk about that next week. Okay. So y'all don't have to worry about that yet. But remember, central angles are the ones that are congruent. They come from the center. Okay. Any other questions on 4? I wonder if we did it the other way, if it will give us a whole number. Let's find out. So 360 minus 84, we'll just chase this rabbit hole real quick, is 276. So that means that all of these arcs share 276. If we just want half of that, it'll be 138. And now let's set that equal. So 4x minus 8 is 138. Add 8 to both sides. 4x is 146. Divide by 4. Thankfully, this wasn't one of those worksheets where it didn't work out right. We got 36.5 again. So even if we did it either direction, we end up with the same answer. That's nice of them, huh? Yeah. Our second theorem, okay, tells me that if a diameter or a radius is perpendicular to the chord, it bisects the chord and the arc. Okay, so what does it mean to bisect? Cut in half, good. If I can write out cut in half. So if we go look at the diagram, it tells us AD is perpendicular to BC. Remember, this upside down T means perpendicular. Okay, so we can draw a right angle right there. What that does, it creates a congruent chord and a congruent arc. Yes, ma'am. It bisects the chord and the arc, correct. What do you mean? Perpendicular means they intersect at 90. Not all lines that are perpendicular are being bisected. But this rule says yes. Way to go, chat. Okay. All right. So given WX is 12, so we'll go ahead and pop that in there. The radius is 13. Oh, they hit us off with a harder question to start. What do we know about any radii in a circle? It goes from the center to the end, good. But what about the relationship between radii in a circle? If I were to draw another radius over here, what would that length be? 13. Well, what if I got a little creative and drew a radius here? What would that length be? This length would be 13. And then what did we form? We formed a right triangle. Since we have a right triangle, we can do the Pythagorean theorem. So if we have a right triangle where we know 2 out of 3 sides, we can always do the Pythagorean theorem. Okay. So x squared plus 12 squared is 13 squared. How did I know to set it equal to 13 squared and not 12 or x? Across from the 90 means it's the what? Hypotenuse, which is our longest side. So it is a special. Good job. It is one of our Pythagorean triples. It's one that we've probably seen more and more. Subtract 144 from both sides. So x squared is 25. And then how do we undo a square root? Our square with a square root. So we know that bottom portion is 5. Okay. So YZ, so remember, since it's cut in half, if that side is 5, then XZ has to be 5, which means the whole length of YZ is 10. So even in our circles, we have our right triangle friends. Friends. Right triangles are our friends. Oh no. Okay. Given the measure of arc DHF, is that a major arc or a minor arc? Major, how do we know? It's more than 180 and got 3 letters. So that's telling us we're not going this way. We're going starting at D, passing through H, finishing at F. So that's 210. They want us to find the measure of arc DE. Since this is perpendicular, what do we know about the relationship between our two arcs? They are, in fact, congruent. So how much of our circle is left for those two to share? 360 minus 210 is? It's the exact answer from our homework, isn't it? So each one of them are being bisected, so half of 150 is 75. That was the exact question from the homework. Silly gooses. What's wrong? Oh no! Not another 30, 60, 90. We should be pros at these by now. Okay? It wants the length of FJ, EJ, and the measure of arc FH. Okay? So let's focus on the arc because that's the easiest one. We don't have to do any math. Why do y'all think I can say we don't have to do any math? What type of angle is this? What type of angle is FEG? FEG. What type of angle is it? It's a 60-degree, but where is the vertex? The vertex is on the center, so it is a central angle. Central angles are what in relation to their arcs? They are the same. So if the central angle is 60, the arc is 60. Since it is perpendicular, if this arc is 60, GH also has to be 60. We will for the side lengths, but not for the angles. So the measure of FH is 120. So that one wasn't too terrible. But yes, we need to find EJ and FJ. So I'm going to let this be X, and we'll let FJ be Y. What's the ratio? 1 to √3 to 2. Okay, that's every 30, 60, 90 on the planet. What about this particular 30, 60, 90? We have our short leg is X, our long leg is Y, and our hypotenuse is 6. So we're going to solve for X. 1 over X is 2 over 6. If I want to reduce this fraction, I can. Probably makes me a little easier. 2 over 6 reduces to 1/3. So when I cross multiply, I just get X is 3. And then we do the same thing to find Y. √3 over Y. Now we could, but before we can. So 2 over 6 we said was 1 over 3. Cross multiply. Y is 3 √3. So that's our numbers. FJ is 3 √3. And EJ is 3. '30, 60, 90s are never going to go away. Oh, look at there. We've got a 45, 45, 90. Reverse. Hey, so they want us to find the length of PR. So this is where you could do the Pythagorean theorem if you wanted, or you could do special rights. Because on the first one, X and Y were different, so we had 2 variables. But since this is a 45, 45, 90, X and Y are X, they're both X, so you could just do Pythagorean theorem. I'm going to go with special rights. So 1 over X is √2 over 8. You could do the Pythagorean theorem. Yep. 64. Yep. It could be easier for some, but not as easy for others. So we cross multiply. Plus, I wanted to practice my rationalizing. You rationalize the Pythagorean theorem? Okay. So we divide by the square root of 2. What is wrong with this statement? 8 over √2. Cannot have a radical in the denominator, so we have to multiply the top and the bottom by the square root of 2, which is called rationalizing. So we get X equals 8 √2 over 2. Will that reduce to be just 4 √2? So we've got 4 √2 4 root 2. So the whole length of PR is 8 root 2. Very good. And our last theorem for the day is in a circle or in congruent circles, two chords are congruent if and only if they are equidistant. Meaning as long as they are the same distance from the center of the circle, the chords themselves will be congruent. And you tie that back to the very first one. If they're equidistant, then the chords are congruent. If the chords are congruent, then what can we say? The arcs are congruent. Yes. So it's like one big choo-choo train. All right, circle F. Why do they call it circle F? F is the center. Good. AE is 6. BF is 10. FG is 8. Find the length of HJ. Is there even an HJ on this paper? Is there even an H? Okay, well, what do they want us to find?
BF.
BF is given. CD sounds fun. We'll find CD. How about that? But we don't have to do any math to get to CD. Okay. Well, let's just write out what we know. We know FG is 8. I don't know what they actually want us to find. So we're perpendicular. But there's not even a J. Yeah. Yep. Who knows? Okay, so we got 6 and 6 because it's perpendicular, it's bisected. I guess we can verify that EF is 8. Let's verify EF is 8. How can we figure out that EF is 8? So, but we don't know that it's equidistant yet. Okay, so let's go ahead. We can do the right triangle. So 6 squared plus x squared is 10 squared. So 36 plus x squared is 100. Subtract 36 from both sides. X squared is 64. Square root both sides. So we figured out and confirmed that they are equidistant. Since they are equidistant, what does that mean about A, B, and CD? They are the same. So that means we could say that these are both 6. So the full length of CD is 12. That would have to be 10 because they're both what? They're both radii. Since they're both radii of a circle, they have to be the same. Our last one, hopefully it's a little bit nicer to us. 11x plus 15. And then WY is 32x minus 27. What do we know in this problem? Why are the chords congruent? They are equidistant from the center. Good. These two symbols showing congruence means they are equidistant from the center. Since they are equidistant from the center, our chords are congruent. So all we're going to do is set them equal to one another. Yes, sir. So 11x plus 15 equals 32x minus 27. We have a variable on both sides, which means we're going to move the variable first. So 15 is 21x minus 27. Thank you. Now that we've got our variable on one side, we can move our constant. Add 27. So 21x equals 42. We're going to divide by 21. So x is 2. They want us to find the length of SU. Hey. So we're going to substitute that 2 we found. 22 plus 15 is 37. So that does it for our lesson on chords and arcs. Have a great day.